Welcome to Superangel's next Flash webinar on how to build your AI startup. And today I'm really thrilled to have Taivo Pungas from Veriff with also experience from Starship on building AI here today with us. Welcome, Taivo.
Hey.
And as always, we collected some questions from you, and I'm going to show the main topics we are going to cover today with Taivo. So, from first of all, the poll results are that most people are mostly interested in learning about how to get from business problem to AI application, and also how to MVP your AI product, that how to do a minimum viable product if you are building an AI. And the other topics we gathered were a few personal questions, lessons learned, questions about building AI teams, questions about AI business models and building products from customer problems, how to do MVP in case of AI product, improving your internal processes, some questions about tools and trends, and one particular case. But let's start with two personal or lessons learned question. One is about your experience as moving from different startups and industries. How did that affect your approach to your work?
Yeah, the first two companies I worked at were Skype and TrustWise, and my role there was basically of an analyst. So I didn't really build models. My main focus was in creating an understanding of data, and in that sense, I would say I barely understood the larger context of my work, and it was quite an entry-level role. So there it was, I don't think there is much to say about those roles. At Starship, I was focusing on statistical software engineering, so solving self-driving problems. But the main approach or main way to solve these problems was not really training machine learning models or anything like that. It was building fast software that is able to solve these problems in an extremely low amount of compute compared to the state-of-the-art models, because the robot hardware is commodity hardware. And at Veriff, I started as a technical specialist, and like 2 months, 3 months into the process, or after joining, I started, or me and a friend and colleague who joined at the same time as me, we realized we need to grow the team. So I took more of a product and recruiter role, and he took more of a technical role. And this has on and off continued up to this day. So right now I'm mainly focusing on product issues. And I would say let's say Starship versus Veriff, I think this is a very one of the most informing comparisons. Perhaps the Starship was when I worked there, it was in the early stages of getting its commercial operation set up, and this is in comparison with Veriff, where when I joined, we just hit extreme growth. And the stage at which you have existing clients, which you have made large commitments to, which you need to serve, it is in some sense very exciting, but in another sense very horrifying, because you need to deliver what you promised, and it's really, really, really difficult. There was a period of time where for 5 weeks in a row, I didn't really, I didn't have weekends. And from a technical perspective, I think Starship was, I think it was probably technically deeper or more complex problems, more state of the art in the sense of being in the frontier of research, and at Veriff, I think the biggest problem is getting a very good understanding of what we need to build. So a product problem combined with a slightly smaller technical challenge than at Starship. It's definitely not easy, but I think there is a much larger product focus because we're in that stage.
Very cool. Now, we just, before going live, we were, there was one question which brought a smile to our faces, and I definitely want to start with asking that question before we go to AI. So the question is, as a founder, how do you keep your mouth shut when working under other founders?
I hope Karen and Janer are not watching. I would say that generally I don't. I just, not that I say whatever comes to my mind, but when Veriff has a very strong culture of seeing a problem, and when you see one, then you try to solve it. So I've made many proposals and changes sometimes across the company, which were not necessarily part of my role. I've also, like, these are the positive cases. There are also negative cases where I'm super frustrated about something, and then either I could go so far as I am very emotional myself, or it's hard for me because I know it's wrong and I want to change it, but I can't. So it's challenging, but I think the best way or the most productive way to make that work has been to, when I have had relatively clear goals, either set by myself or my manager, and then support, but freedom to execute towards those. So relatively hands-off approach. So I like my freedom. I don't want to give that away.
Very cool. So going to the AI and business cases. So let's start from what kind of business models you can actually build for AI startups, or use for AI startups, or how do you see it? Like what kind of businesses we can build using AI?
I thought of this question beforehand, and it's almost like enumerating all possible business models, because AI is more like, where can you apply JavaScript? What business model can you apply JavaScript to? It can create value in most businesses probably, but so typical ways to like concrete ways to do that. You can sell decisions. Amazon, for example, you send them an image and they send you back all the transcribed texts in the image. So they have an OCR API, and they sell you, each request costs something like, I don't know, 0.01 cents. That's one approach. You sell a service basically. You could sell an SDK. So there is a company, Ukrainian company, which sells its SLAM, so simultaneous localization and mapping API SDK to, I think, chip makers mainly. So they integrate it into the edge devices, the mobile phones, etc., that they offer, and then that phone has relatively good, AR capabilities. And I don't know the details, but I think their model is licensing, and I don't think it may not even be per device. It could be, just this company, they buy a license for $10 million. That's one approach. Let me see if I have other examples. You could also provide, you give a SaaS pricing model where you pay a fixed fee every month, and then you have a usage cap, which is quite similar to the per request format, but not exactly the same. So it's more like bucketed version of the same thing. But the same the same applies to almost any software product. So I don't think it's super different. If you want to sort of generate for yourself ways, coming from the technology side or thinking what are the places that AI could create value in, one very clear case is where you take a human job and automate it. So either that makes it cheaper, faster, more scalable, perhaps there aren't enough skilled humans to do it, etc. So could be this is not really about the monetization, but it's about what value the product can create. And you could have like radiology, image interpretation. You could have self-driving is an example of that. I'm sure that many relatively simple computerized tasks can be automated that way. Accounting, perhaps going from a bill to accounting entry, and I think it's probably been done, I would imagine. So that's one way to create value. The other way, which is very common in consumer apps, is search. So for example, if you look at the Volt app, their search, I would say, is not very great. A better example is Netflix. So if you search for, what would be a good example of a TV show? Let's say you search for, I think you're muted, Caleb.
Yes. So Office.
Right. So you search for The Office in Netflix, and if they don't carry that show, if they don't have it licensed, then they will actually detect that you searched for The Office and then show you a show that is very similar to it. For example, Parks and Recreation. It might not have any word related to The Office, but they will detect it based on they will detect your search intent and then show you relevant results. Another example is, and you could actually, I think this is relatively domain specific, but you could maybe build something across different industries, like a search engine for real estate based on the content, a search engine for car markets, etc. There is also recommendation, obviously, but I think this is main, like the generalizing recommendation service, like Netflix recommending you movies based on movies that you have watched before. Amazon offers this service, I think, and I'm not sure how valuable this is. It's perhaps a bit too horizontal. I mean, we could go on and on, but I think this is a bit too generic question for detailed answer.
So let's you mentioned, like we talked before, that you see there's a kind of mismatch of or dissync that between going from AI, that we can build this cool technology, build these algorithms which can learn something, and then business problems, and vice versa, going from business problems to the AI applications, or solving these business problems with AI applications. So what's your insight there? Where should a startup start, or how to be smart about it?
So, like, in the order the answer is popped into my head. First, you shouldn't do AI just because you want to do AI. You should solve someone's problem, and if AI is the right tool to do it, then you should use that. But I've seen it before, and not once, but several times, where all investors care about in your pitch deck is, in the pre-seed, seed, or seed stage, is like, how can you use AI? And like, if you're building what's an example, a counter example of AI, like you're building a dog food production company, like, do you really need to use AI? Is it a core part of your value proposition? And I think people are focusing too much on how can I use AI, or how much is it really a big advantage in your business? And in most cases, I think it may be like a nice feature, it may be an optimization, but it's not the core thing. For example, Starship, like, if the robot doesn't self-drive, the business model just can't make sense. Veriff, more or less the same thing. It's not a very attractive business if you cannot automate that all. In contrast, let's say Netflix, like the core service works kind of well, and the value that their recommendation engines and the search and all of these features create I think these are more about retention and engagement than they are about the, that Netflix could not do without them. So yeah, I think people over-index on like the whole AI hype, and I think we're actually coming down from the top of the hype cycle of AI, because the R&D labs, or the AI projects were kicked off with large amounts of money in enterprise and everywhere several years ago, and now it seems that the results are not really, it's perhaps not that broadly applicable, not that necessary in many cases, and people are starting to realize that. I think one example, notorious example, is DeepMind, which it's like public interpretation of publicly visible things, but it seems that Google wants more control over DeepMind, which has been a very research-oriented organization, and wants to bring it more closely together with its normal operation. So my recommendation, maybe separate in your head then two things. One is what you tell to investors, and what you actually commit your product roadmap to. And the product roadmap should follow what creates the most value for the company. And if you want to make strategic bets on AI being a part of your product in the future, then that makes sense. But then the preparation you should probably do is more about collecting data and figuring out what sorts of data do you need, how do you set up your product so that it can be easily automated later, or easily AI features could be added later. So it seems a bit forceful in many cases. But actually, just one more comment. There is a counter, like this is like the top-down, or let's say business to technical side, where you think, how could I apply AI? There's a separate direction you could come from. You could be like, okay, so I have this model, or I have this system. How could I monetize it, or where could I provide value with this? And there's nothing wrong with this sort of technology push, but I think it's less likely to work. I have a friend who I've made a bit of fun of him a couple of times, because he really likes to do technology pushes, and he's I wouldn't say failed, but like he hasn't found as much traction as he's wanted over the couple of times he's done that. And he's like one of the best people I know in the field of computer vision.
So the best start would still be like a business problem, in which case making it cheap or automating it could be become like a core business core of the business, or the main value prop. So what other attributes you need? Of course, there has to be some kind of data component, because in many cases the automation actually doesn't need any AI, but you can automate using other techniques or tools, so you don't have to do the complicated or difficult machine learning part. Or what's your take on it?
It was a long question. Can you shorten it?
Yeah, sure. So basically that what are the other criteria that, in addition to, like, I start from business problem and I want to automate a business or make it cheaper, the process, but what else in addition to like ability to collect data, what else should be there in this case that I can actually benefit from using AI as a tool for solving the business problem instead of automating it some other way?
I think so. Maybe a separate or sub question to consider here is what people mean by AI, and I think that the not explicitly agreed, but the colloquial usage of the term is anything that feels intelligent to the person seeing or using that product. And okay. It's a completely unrelated to the technology behind it. It could be a couple of if sentences and lookup from a database, and people might call it AI. One of the first chatbots ever made was extremely simplistic. You could probably implement it in less than 100 lines of Python, and the users who tested it, it was in the 60s, I think. The users who were asked to test it, they could not believe that this is not a human. Mm-hmm. So when I say AI, I mean the functionality, or yeah, it's kind of underdefined, but there's a technology component where it's machine learning models, deep neural networks, technical systems where you optimize parameters against the data set in a more general way. But there's also a product component where it feels intelligent, and you can get the feels intelligent part, at least like 80-20, you can prioritize it without building any models, without having much data, a couple hundred data points maybe. So I defined and answered my own sub question. What was the actual question? Sorry.
Very cool. I think it was very important that you defined what type of AI we're talking about, and I really like your definition of anything that looks intelligent to the user. So the question was that if we start from a business problem and try to validate that, is this a good problem to solve with AI as a tool? That as an outsider and incompetent, that one thing I assume is important is the data, that I need to have enough data points to make anything to able to use neural networks or a comparison to some set. What else is necessary, or how would you evaluate that? Is this a business problem we should use AI to solve it?
Right. So ideally, I would generate a flow chart for should I use AI or not. Mm-hmm. Data is definitely one big part, and you should have enough of it in just the volume, the repetitions of usage of your product. So, for example, if you're doing a product that improves enterprise sales, then if one company makes 10 sales in a year, which total, may combine to 100 million in revenue, there are too few repetitions to probably do anything meaningful. And even if you could, it's probably not worth it because a human could do it. It's the amount of money is so large. There's a question of value, right? So if it is a highly repetitive, so if the count of it, if it has to be done many times, a large amount of times, let's say across the whole market, billions of times, it's done across the world billions of times every day, and it is possible to generalize it or just extract it into a separate component, then it might make sense to do it. For example, a counter example here is that I use my hand several times a week to pick something out of a shelf in a store. But this automating this in itself is, it doesn't fit into any place. It has nowhere to attach to, as opposed to, in the case of Veriff, taking the inputs or the images of a person and their document and using that to give a verification response. This is a relatively well-defined problem, and it can be done, or you can approach it, and it creates value if you automate it, because it attaches to existing interfaces with the client.
So
yeah, one more
repetition.
There's also data repetition. There's also you can make a simple value calculation. So very roughly in Estonia, if you hire an engineer, that's something like 50,000 euros a year, the salary cost. And if you can't see a feature or whatever problem you're solving creating that much value, there is no point in hiring a data scientist. And I've heard this from a major bank in Estonia, that it's not even AI. Spending development resources like normal software engineering, building a web app, for example, or some data flow, it is not worth it because it is cheaper to continue paying the people doing this manually. So, this is like a obvious back of the napkin calculation. So what did we have? Data, repetition, money. There's also a technical feasibility, of course. So it turns out that self-driving is perhaps harder than we thought, but I don't think anyone thought it was an easy problem, let's say 10 years ago. And if what they're trying to do, I think a good test of this is if a human cannot do this based on the input available, then it is, it's possible that that you can do it with some sort of machine learning approach, for example. But if a human can do it easily, if it's easy for me to differentiate, the classical example is cats and dogs from images, and it's trivial for me, then it's probably possible to automate. But if I have let's say images of the sky, like if I take an image looking up and I have to predict the weather 7 days from now, it's kind of unlikely that a human could do it better than random, and also unlikely that an AI could do it. So this is something that's, the edge cases or the extremes that I brought were perhaps clear cut, but this I guess is domain or technical expertise that gives you this understanding of how difficult the task is to automate.
Good points. So going to the using the MVP or minimum viable product and AI. So in startup world, it's like common principle that you should build something which kind of works, does the minimum requirements for the customer in order that for the customer to see some value in it, in using it, and then you should test and go with it. So build as fast as you can something which creates value and offer it to customers. In AI, you have to train algorithms to do something, and it seems to that it requires more time and effort in order to build something minimum. What's your take on it? So
the question is how to scope things down so that it is feasible for an MVP, or how to choose a minimal scope so that it still creates value. I think this is generally a difficult problem in any product, and in AI, some patterns I've seen over the past couple of weeks. I've done many calls with entrepreneurs building their startups and hoping to use AI. You have to be extremely clear about what your prediction task is. What is the input? What is the output? And this is basically like, once you have this defined for yourself, that's like when you can start discussing how difficult the problem even is and what sorts of value it can create. So if you tell me that, I want to predict stock market prices like in the future, then it is very undefined. Like, what's the input? Do you want to just do the time series analysis where you take the history and try to predict the future? Do you want to use satellite images of I don't know, shopping mall parking lots to figure that out, or factories of the company that you're investigating? So a concrete example of this would be, I want like the input is satellite images of Ford factory, a Ford Motor Company factory, this, let's say today at this time, and my prediction is about the stock price tomorrow. This is kind of the place where I would be suspicious of whether it's even possible. Like, could a human do it? But reviewing the data, maybe there is some pattern. So once the input and output types are defined, input is an image or a set of images, and the output is a real number, then you can assemble a data set even of 5 examples. This was the image, this was the price the next day. And once you have this data, it shouldn't take you long to collect this data. Like, you can, if you have a running product, even if you have very, very few users, you can get that, or in some cases you can get it from public data sources. So once you have this sort of concreteness, you can, like I said, based on intuition, you can figure out how difficult it could be to solve from the technical side, or you can also run some experiments against this data. But from the product side, you can sort of investigate or discuss with your clients the features you could build on top of this model, or on top of a particular accuracy on this task, for example. If I'm right, or if I predict the direction of the change correctly in the stock price, I mean, correctly, I don't know, 80% of the time, is it valuable? Taking it into account all the fees, etc. So I think the problem, or the anti-pattern here, is staying very vague about the prediction task that you intend to build, or that you could build hypothetically. And if that is vague, it is very difficult to understand what the product value could be, as opposed to being extremely concrete about this with even examples, and then you can go into these discussions with clients or internally what you could build on top of this.
So you mentioned that this was like one of the challenges also from the startups you talked with. What other problems or issues you heard during the discussions with the startups, and what was there any common topics?
A couple. So one, like the one I mentioned right now, that was one. Second one, I think it is relatively uncommon to define the task with a data set. So this is a very particular way of working. If you imagine the way a typical software team works, the product manager writes a story, an epic, and then maybe some tickets. The tickets have acceptance criteria. The engineering lead that touches the effort estimate, and then they take it into the sprint, execute it. And at some point, maybe there's, depending on what stage you're in, there's some testing QA process, and then you release it. It is typically in this process, you either define the task with words in the ticket, or with a prototype, or some wireframe, or some design input. And this just does not work for a prediction problem. For example, if I try to detect, or if the goal is to detect whether an image is too dark or not. So in Veriff, for example, when you take an image of your face, we need to figure out if it is too dark, the lighting is too bad for us to even make a decision about it. So we need to detect that. And if you're starting out, you might take a couple of photos of yourself in the office, and then some are too dark, some are not dark, and you can create a data set like that. But as time goes along, you will find out edge cases. Maybe someone takes an image which is completely black. And should you even say that like the face is too dark there, because there is no face? Maybe there is a face, but it is out of frame, like something like this. This is the face too dark. So you figure out all of these edge cases, and you need to get really good at this game of, like, your data game needs to be really strong. You need to be able to update your data sets. You need to be able to iterate them. You need to be able to push them out to data scientists, evaluate your algorithms against this. And this loop needs to be really, really good. And this is something I think very, very, very few people in the world realize. If you look at Starship, was very good at this. I am trying to be very good at this. If you look at Tesla, most of the director of AI of Tesla, most of his effort, and he says so himself, goes into how to label data. Nothing about like the technical architecture, etc. This is much more simple, or much more straightforward compared to how to work with the data. So I think there is some indication that the companies or teams that have to practically work with, get to production grade with their AI systems, they need to get really good at it. So this is another pattern which I'm actually in the process of writing a post about, because this is such a common issue. Third one, I think this relates to the previous one, but there's a question of how to evaluate an AI system. But this is actually quite, especially if you're not a technical person or you don't have data science background. For example, you're an engineer or just a CEO or product person in a company. If you have created the data set, it is extremely clear or kind of trivial to define a metric on this data set. You can say, like, I will run the system you built against this data set of examples, could be 10 examples, and I'll see what percentage of time it is correct. And that's accuracy. If you want to go into more detailed metrics, this is typically what they teach in machine learning one-on-one courses, precision recalls, etc. But it's even a very small data set and very simplistic metrics are better than just like using words or testing against anecdotal data, just trying it out yourself, which can also be valuable to figure out whether you're not over optimizing for some cases, but to be systematic, you need this testing against the data set. I think all of these problems actually relate to like this development hygiene or development processes which have been very well developed for other kinds of software, but not so much for data science systems.
So we talked about the scoping. You mentioned that this how to label is like a key issue. What's your advice in there? You mentioned kind of you are going to write a blog post about it, but what are the
what's the content of the post?
Summarize it quickly, please.
Yeah, like the pitch is actually quite simple. You need a specialized function to do it. It cannot be the data scientist, because the data scientist, like, you're probably paying them quite a lot. That's like one problem already. Second, they are not an expert, like they're the technical expert, and you don't want them to be labeling data. They should sort of get familiar with this, but they shouldn't be labeling data at scale. Third, the problem is if you have a technical person label the data, the data set basically defines the goal of the system, because that's what you optimize against. If the technical team is capable, the system will achieve exactly what the data set tells it to achieve. And in that way, the product specification is the data set. Like, I think I explained this before as well. And you want there to be significant product input or product guidance into the definition of the data set. And since this actually, it requires both the sort of high level guidance, what to do in these cases where the image, where the face is out of the frame, is it too dark or not? And very detailed granular labeling, like you need to go through 1,000 data points or 1,000 images and attach a label, is it too dark or not? And at Veriff, the approach is basically a collaboration of product and the team called data ops, data operations, which is responsible for creating very good data sets on a very, very detailed level, and making them available for data scientists. So data ops collaborates with the product and data science teams from the product side to make it very clear what the intention of the product is, and then translating that into the single image level. And then the data scientists can work with these data sets built by the data ops teams. And this is actually the term data ops, it's overloaded. It's also used somewhere else. And in other companies, I've seen it called engineering operations or data annotation and similar names. So since it's not a standard function, at least not yet, it will carry completely different names.
So going back to the MVP, we had a few questions about that. If you build your first MVP, how to make sure that you can scale it later, or do you think it's important, or you can, after figuring out that it's right direction to go, you can build something else which is scalable, that you proved that it's the right direction to go?
Yeah, I think the generic startup advice here applies, that you're like, how much should you think ahead, or how much should you think about scaling, for example, technical debt, etc. So what's your investment horizon, basically? If you're a 2-person company, you have like half a paying client, so like one pilot, then you probably shouldn't worry about it too much. You should worry much more about delivering value in the first place. And if you're if your company is scaling, your operations are scaling, you should worry about that more. Perhaps there are several dimensions of scaling. You could scale in the number of, in the case of Veriff, number of verifications done, or Starship, number of orders done. So like amounts of units of value produced. You could also think about scaling in terms of the number of people in the team, and your process and your, the tooling, etc., should support scaling the team when necessary. But if you're not planning to do that, if you're not expecting growth in either direction in the next 3 months, or whatever your investment horizon is, you shouldn't probably think about it too much.
Relating to like scaling up and learning through the process, there's a question about how to avoid a mess of data sets and models from different experiments.
I also thought about this before, and I don't know a good solution other than being like there is no robot that will clean up your room for you if it's full of mess. It's maybe one comes along in the future, but today there isn't one. You have to pick up your own socks. And similarly, there is no magic solution. If you don't name your experiments, if you don't record the results of your experiments, then it's kind of, I don't think there is a solution that does that for you. There are tools that try to, using good design, they try to force you to do the right thing. And one interesting one, which I've looked into, but not used because it seems a bit too early, is it's called DVM. It tries to be the Git for data science or something. So they version, in addition to code, they version experiments and datasets and model files. So I think this is something to check out. There are also other competitors. So this is like a very generic category of startup, like experiment management for AI teams, but I don't think many of them have been successful.
You started to mention tools. There was a bunch of questions about also tools. That anything particular you want to recommend in addition to looking into DVM?
DVM it's not like a strong recommendation. It's specifically for if you care about that problem, if you want to understand that. I think there were several questions about programming languages. Like no one, and I mean like literally no one in machine learning research or applied machine learning uses anything other than Python. Like everything non-Python is downstream from Python. It's sometimes several years behind Python. There are exceptions, like if you want something that's really fast and like reasonably accurate, people build that in C or C++, like Darknet, for example, or the YOLO model. But typically, like the bulk of the volume of the work is done in Python. The data scientists are like, that's their standard language. And if you choose anything else, you had better have a very good reason and a very strong community of people you can hire from for that, because otherwise you will it's not going to work. And by the way, you can, depending on where you deploy your system, if you deploy it on an Android app and you need to do on-device compute or on-device modeling, then you might consider the choice of whatever language runs on Android, Java or Kotlin or I don't know what other options are there. But if you don't have such constraints, there's no reason to do anything other than Python.
Very cool. Anything else regarding tools or architecture? This is also how to build up your stuff in a most useful way.
One tool I can recommend is, if you're doing computer vision, use OpenCV. If you don't want to pay for commercial labeling tools, OpenCV, under that open source like umbrella, there is a project called CVAT, CVAT, and that's a labeling tool that's not just myself, but a friend of mine who is running a research group. He said that based on their research, this was the most valuable open source tool they found. So there are also commercially available tools, but depending on your use case, they can go into hundreds of thousands of euros per year. So you must have a big budget for them. Architecture-wise, I think mostly it will depend on like your developers and the engineering team. Like there are also all these patterns which I don't know that much about because I'm not an expert in software engineering. Like I don't know microservice architecture. There are pros and cons, or like do you never mind that. Actually, there is one recommendation I can give. It's not so much about software engineering even. It's about structuring your prediction system. And I think in the early stages, it makes sense to build it in a modular way. So don't try to, build a neural network that you feed in 1 million labeled examples and it gives you a response in a black box way. It probably won't work. Like it's a huge amount of effort. It's basically waterfall development, and you end up in 1 year, you might end up with nothing. So solving more concrete tasks, maybe subsets of the whole problem that are already creating value. So building this like step-by-step roadmap from many components. And as time goes along, as you get more labeled data, you might be able to swap out some of the handcrafted components of your system with a neural network. This is something we have done, and Tesla, I think, in their public presentations, this is something they've said about their architecture. So this is a pattern that seems to work.
We've talked about tools, MVPs, common problems, and you mentioned kind of about how to build the AI team in terms of combining, or in case of labeling, how you should have a triage between a product, the data scientists, and actual op people who would do the labeling. What other suggestions you have regarding how to put the software engineers and data scientists to work together as a united team?
Yeah, this is also actually a question that I got from a startup working on not like super early stage, but already kind of ramping up their development. So there are two ways. The first one is wrong, and the second one is the way I do things. And like you'll understand why it is wrong while I explain. So the first approach is to, like, data scientists, they build a model, they hand it over. There's a strict handover to a software engineer, and then the software engineer productionizes it. But the problem is the data scientist is probably not hired for their ability to write like production grade code, and then the software engineer takes over someone else's shitty code and has to make it work properly, scale, etc. And neither side is actually happy with it, because from the data scientist perspective, this takes a long time. From a software engineer's perspective, they have to fix someone else's bad code. A better approach is to, instead of having this huge cliff, have this gradual ramp. So as the data scientist first experiments with things, she can just individually experiment, because they're not even close to production. But as you move closer to production, she works together more with the software engineer, improving the layout of the code, improving the scalability, reducing repetition, working in all of the testing, deployment, etc. pipelines. And at the very end, when it comes to building a functioning service, maybe at the very end there's a component of the software engineering working alone. But there shouldn't be this clear-cut handover. I don't think this is good. There's also benefits if you do this ramp up. You can do actual pair programming, and this is something I've seen work well at Veriff. So the data scientist and the software engineer work together. What happens is that it drops off on each of them. So the data scientist understands how the software engineer works, learns something about that, and vice versa. And this is both motivating and also actually improves long-term the quality of delivery, I think.
Very cool. Another case for good application for pair programming, and why is it good? We are soon, we have like 10 minutes, we're running out of time. What are the other topics you would like to cover, what we haven't mentioned yet?
Yeah, I think a lesson that maybe hasn't come through as strongly as I wanted here is try not to use deep learning. Try not to use anything you consider AI unless you absolutely have to. And the first solution you consider should be, an if-else statement, something extremely simple, because that's extremely maintainable. And as you understand, as you test your solution against the data set, even if small, if you figure out that this approach cannot solve the problem, you can go into increasing layers of complexity in solving the same problem. The next layer might be that you have this simple approach where you can change one threshold or one parameter in the code, and that changes the behavior. So you optimize that against the data. A more complex approach may be that you train a very, very simplistic model on the data, or you could use an API that like an Amazon API behind which sits a neural network, but you don't really have to think about the complexity of the network, like how to run it efficiently on GPUs, how to get the training data, how to run the training loop, etc., etc. So try to avoid training your own models for as long as possible. But when at some point you will have to, because some tasks simply cannot be solved another way. And you shouldn't, I would be surprised if you reach that point with more than a couple of problems in your whole stack, because I think most technical problems of this kind can probably be reduced to they can be split into components and solved in an easier way. I don't know. Maybe I don't have enough generalizable experience here, but this is what I would urge people to do: avoid the fanciness and try to build something that works quickly.
Words of wisdom. There's one specific question about complexity and retraining. AI products often consist of many small machine learning models, sometimes forming complex dependency graphs. How to deal with models which could give drastically different results after retraining and influence everything downstream?
Yeah, I also thought about this question. I think the question implies that the intermediate result produced by the neural network or the model, you cannot evaluate it by itself. So, for example, if you wanted to build a system that takes speech commands and turns them into actions or does something based on that in your app, then you might have two parts of your pipeline. The first one turns speech into text, and the other one turns text into the actual action that needs to be taken. And if the network trained on the model built to solve the first part of the task, if that changes, but its performance does not change, it is as good or better on the task of turning audio into words, then it shouldn't be a problem. It can't be a problem, because if the downstream model relies on some weird behavior of the previous model, then it's probably the downstream model is wrong. But if you build the system up in a way that you produce some embeddings or something that is not possible to evaluate by itself, or maybe just changes based on the randomness inherent in the training process, then there's no other way than to retrain. I think if you depend on that on these, or if the downstream model makes assumptions about the previous one that are not possible to evaluate.
Good. Then there was a question about simulations, that AI and simulations, that is this the most reasonable way to collect and train real life systems than that interact with environment? Or what's your opinion on simulations?
I haven't seen, or I haven't personally experienced any place where a simulation would be worth the effort put into building it. I have heard of Like I have seen presentations, especially in academia, there are many, but I have seen presentations from, I think it was Cruise AI or some self-driving company where they could create some value out of it. But the problem with simulations is you have to be extremely creative to come up with all the garbage that is in the data that your production system needs to take in. For example, in the case of self-driving, if you want to simulate a car driving around the city, like the city part, maybe you can get it right. Like there are city simulations that maybe these are perfect. Like assume this is solved well, but the hardware you're using, like you have to simulate the radar input, for example, or the depth camera input, or the LiDAR input, and your simulation would need to model the particular noise profile of that sensor. That's one thing, like the physical component. There's a component of you doing, like just implementing that sensor in the wrong way. Like a bug in your code, basically processing it, but it's not as bad to make it garbage. It just reduces the performance or the accuracy of the sensor. The systematic failures of radar. Some objects are much more visible in radar than others. In some cases, your camera is overexposed, underexposed. Like you have to model all of this complexity, and it's probable that it might be easier for you to invest into acquiring the data in a different way. In the case of self-driving, like paying someone to drive around the car to get that input. I think that's probably the reason. Like it's really, really difficult to build a high fidelity simulation.
All right. Any final words for startups building AI products? Besides that, use if-else commands first, and then necessary scale up with AI and deep learning.
I think I'll just repeat my point from before, that be extremely clear about what you want to predict, the data types, and then build a very, very small data set to start, and then scale the data set as necessary. And if you do that, this is extremely simple. Like any data scientist will tell you that this is necessary. If you're able to do that, I think it's common that doing the basics well will take you to the top 5% of everyone. And I have seen very few people who do the basics well. So just try to do that, and you'll probably be better than most of your competitors.
That's a very good recommendation to end with. That world is not so difficult if you do your basics right. So thank you very much, Taivo, for this chat today, and I learned a lot. So those guys who signed up for the event will get my notes in coming days. Thank you, Taivo, for joining.
Yeah, and if you want to get notified about the blog post, which I hopefully, yes. I'm not committing myself, but probably in like 2 weeks, I'm doing feedback rounds on it right now. Go to taivo.ai and you can sign up for the email list, so you can get updates on the posts. Very cool. All right, thank you for listening and watching, and see you around for next great events.